What is the p-value? Well, first thing to know is p-value is a probability. So when you do your homework assignment on an exam, if you see an answer that is 1.78, or if you're doing the calculation and end up getting 1.78, could it be the correct answer? No, why not?
That's not a probability.
Because it is not a probability. Elaborate, listen.
Because a probability is a number that lies between 0 and 1.
A probability has to be between 0 and 1. Of course, it can include 0, it can include 1. Example from last time. Effectiveness of an anxiety drug that just came up the market, whatever. Sarah had a cutoff for her to consider the drug to be effective, and that cutoff that Sarah had in mind is 0.7. Is that definition, does it correspond to a unidirectional test or a bidirectional test? Unidirectional test, to be very specific, which direction? Right or left? Right. So, right tail test or right-sided test. Naturally, unidirectional. If I rejected the null, I'm going to say that there is an effect. If I don't, the drug is not effective. Again, we are simply trying to assess using the sample if there is enough evidence to support the statement that the drug is effective. Good. Okay. We did have an estimate we had in our example. I just mentioned it. What is that value? 489? So we have the proportion of people who concluded or who responded that the drug is effective using a sample. When I wrote the interpretation last time, I explained it in words, and at the very end, within parentheses, I wrote the value of B hat. In research articles, when you look at them, they will give you a few more items. Facilitate that, I am going to put M and to be, let's say, 96. Do keep in mind, we did not do a problem to get these numbers. I'm simply making them up so that you understand the initial concept. Later, we will do a full. October 2023, what is N? Or from 2023, what is N?
The sample size.
Very good. The sample size, simply the number of participants. Well, 89% of 96 people, that's a good amount. Yes, 94 something, reasonable. Oh, is it 94? No, 86. That is still a good amount of participants who concluded that the drug is effective. Great. We picked a cutoff. What is the cutoff value? I believe 0.25 is the right choice. Come again?
1.645.
I meant to say level of significance. So 1.645 is the cutoff Z-score. How did I come up with that value? Well, I chose an alpha of 0.85 to come up with that cutoff. Good. And do keep in mind, we need that alpha to have this cutoff. No alpha, no cutoff. You can't make a decision. I made up a Z-score last time. Was it 1.8 something?
1.82.
1.82. That Z-score comes from a sample. We have a formula to get that value. May or may not get to 1.82 if we use this. This is arbitrary for that sample size. Again, I'm doing this so that you understand the initial concepts. I'll put in there. We will do this later. Great. Going back to the beginning, we assumed the null to be true. Agreed? Initial assumption, null is true. That is our reference points. Null is true simply would mean that the drug is not effective. Then we went to conduct the experiment, we perform the experiment using or study using 96 participants. They all responded, and we came up with these values. Based on that, what is our conclusion? Amelia?
Based on the experiment using a 0.05 significant level, the anxiety drug is found to be effective.
Very true. That is the interpretation. Step prior to that, Amelia. How did we get that interpretation? What made us come up with that?
Since sample score is greater than the cutoff score, we reject HO.
Okay, Riley, you were about to say something? So Amelia gave an interpretation, and I asked, well, how did we come to that conclusion? And then you raised your hand.
Oh, I was gonna add that it was significantly, yeah, I don't know what I was gonna say.
Okay, Rachel.
I was just gonna say, since the shaded region is the region where we accept it and the other regions is just a rejection, since it's a follow rejection.
Okay, I apologize, I'm using a green marker. I'm not a fan of green markers. But I forgot to grab markers this morning because I was focused on the presentation earlier. I actually borrowed it from one of my students. She even has a label. I asked her, beggars can't be choosers, but I did ask her, do you have a different color? She gave me a look. It's okay. So drug is effective, and we came to that conclusion because 1.82 crossed a cutoff, I think. Good. Now, if you go to one end or the other, in statistics, we call it an extreme. Now, in real life, when we say extreme, it means something really out there. But in statistics, extreme simply would mean we are going very close to the tail end, relatively an extreme. Okay. Conclusion. Is there evidence to support that the drug is effective? Yes. Question is, why? Well, we got a value for a Z-score, 1.82 from the sample, and it exceeds 1.645. The cutoff that we pick using alpha equals 0.25. Now, I don't want to get rid of that. Can I erase this part? You can write it below, but I don't have space, so I'm going to write C, pointer C, over here. It exceeds 1.82. Not only that, We are going to mention that the z-score from the sample let's use a fancy word, extreme. Good. You may ask, well, why is it going to this extreme? Back, so. Moving on. I am going to relate this to a p-value. The formal definition of a p-value deals with extreme. If you Google whatever I'm going to write, is what you will see. Personally, it is sort of a convoluted way to explain what's happening. So I'm going to write an informal explanation after. So this is the definition of a p-value. We did not do a problem, so you don't know the actual p-value. I'm telling you, based on experience, the p-value is going to be less than 0.05. Good. Savannah, you want me to read that out?
Yes, please.
So p-value for the test is less than 0.05. Within parentheses, I wrote given to indicate that I'm giving you this value. If you have to take a guess, what is 0.05? From earlier today, the level of significance. So, connect the dots. That's great. But what is p-value? Okay. What's a lengthy explanation? Let you write that down. So, under the assumption that the null is true, the chances you find, fancy word, extreme or more extreme, 3.44%. That would simply mean there's something wrong with my assumption. There is not enough evidence for my assumption. Salting cracker example, 1 in a million. You're assuming salting crackers are sweet. You came up with an extreme that happened with the probability that is very, very small. That happened because you made this assumption. So is your assumption valid? No, something's wrong with the assumption. So you don't have evidence. That's what that means. Formal definition. Does this make sense? Yes. The informal. It simply says the amount of support in a probabilistic sense, offered by the current evidence that you have towards the norm. So in simplistic terms, we are saying for the anxiety drug problem, the chances that the data supports the null is only 3.44. 3.44%. Is that a good amount? Not good enough. If it were to be 99.7%, I would stick with the null. Yes?
Yes.
That said, do you like this version? That version? Obviously. I took the time to explain that because it's important. To go over this before we have the next class. We're pretty much done with chapter 4.